In the previous video, we learned two methods of approximation. A trapezoidal, written by Tn, where n is the number of rectangles, and Mn, which is a midpoint. Now we need to understand which method is better or have a way of comparing these methods. The way to do that is using errors. Since we're approximating, when you approximate something, there's always an error because there's an actual value that you're approximating. It's good to know how much error is expected. In general, for any quantity, the exact thing is the approximation plus the error. So I can say the integral of f of x from a to b equals the approximation plus error, so that the error is actually the integration minus the approximation. Now let em denote the error using midpoint and e sub t denote the error using trapezoidal. Now here's the rule. It says that suppose that the second derivative of the function f is less than or equal to some number k in that interval a to b. Then the second derivative in the interval a to b, then the error from the trapezoidal rule is bounded by k times b minus a cubed over 12n squared, and the error by the midpoint rule is bounded by k times b minus a cubed over 24n squared. Now concept check: for the same n, which method has lower or lesser error? So let's answer that question with this example. We approximated 1 over x integral from 1 to 2 using both methods. Let's find the error estimate. Now in this problem we were using n equals 5. F of x is 1 over x. Finding the derivative gives me negative 1 over x squared. The second derivative is 2 over x cubed. Now our goal is to find a upper bound for this. Upper bound meaning find its maximum value and see if it is finite. Now because we are in the interval 1 to 2, x is between 1 and 2, 2 over x cubed is going to be less than or equal to 2 over 1 cubed equals 2. Another way to understand this, if x is greater than 1 and less than 2, then x cubed is clearly greater than 1 and less than 8, which means 2 over x cubed is surely going to be less than, if you go with 1 over x cubed, is going to be greater than 1/8 and less than 1. So 2 over x cubed is going to be less than 2. Which means I can choose my k to be 2, f a is 1, b is 2, and n is 5. Solving it or plugging these numbers, I get the error from trapezoidal rule is 1 over 150, error from the midpoint is 1 over 130. Which means, what does that mean? This is a lesser or a lower error. So it is a better approximate in this case. Now, how is this useful? Well, it comes in handy when we have to decide how many rectangles to use. Because these integrals appearing in physical applications, sometimes you may need an accuracy of a certain significant digit. But you need a certain accuracy, which means you need to choose how well to approximate them. And that choice boils down to you deciding how many rectangles to use. So let's understand this. So the problem is to find how large should n be to guarantee that the trapezoidal and the midpoint approximation are accurate to within 0.001. That means that is the max allowance for error. Now we already know that the second derivative of this function is less than or equal to 2 in that interval, so we can pick k is 2, a is 1, b is 2. Accuracy to within 0.0001 means that the size of the error must be less than that, or e sub t should be less than 0.0001. But then we know e sub t is 2, 1 cubed over 12 n squared less than 0.001. You solve the inequality and you get 40.8, the nearest n being 41. For midpoint, however, instead of 12, you have a 24, which means you end up with 29. So again, you need fewer with midpoint. Let's look at some examples. Use n equals 10, the midpoint method, to approximate e to the x squared from 0 to 1, and give an upper bound for the error. A is 0, B is 1, n is 10, delta x is 0.1. So this becomes delta x f of 0.05, 0.15. Again, you can find this by adding delta x. You keep adding delta x after you find the first midpoint, which is at 0.05. And this is at 0.15. You plug in that into the equation. It's x squared, so remember this is e to the 0.05 squared, which gives you 0.0025. And you end up with 0.46. Now let's see how we can find the error. We need to find a second derivative, which comes out of this complex expression, where you can factor this out as 2e to the x squared and 1 plus 2x squared. Now my claim is that x is between 0 and 1, which means x squared is less than 1. So I can replace this whole quantity is less than 1. I can replace x squared by 1, giving me 2e. 1 plus 2 gives me 6e. So k can be 6e. A is 0, B is 1, n is 10, giving me 0.007. We're going to learn another rule in the next video.